Hi everyone, I'm Won Lee. Section 3, Estimation of Error Variance. What is error? Error in the model is epsilon. Epsilon follows normal distribution with mean 0 and variance sigma square. So we like to estimate that value, sigma square, right? It is very important follow that error variance because it is pre-assumption of regression model. Well, let's see. Estimation of error variance sigma square. Remember, yi model is beta 0 plus beta 1 xi plus epsilon I. Epsilon I follows normal distribution with mean 0 variance sigma square. We like to estimate sigma square, okay, here. How to estimate sigma square? What are the data in the case? That is what? Residual. We call this residual, realized value of error. Okay? What is a residual? Residual is yi minus beta 0 minus beta 1 hat xi. So, simply yi minus yi hat, right? Yi hat is estimated line, estimated equation. So this is a residual. So how to estimate the sigma square? That is the like sample variance. Okay, so let's see here. EI minus E bar deviation. This is its mean of epsilon, sorry, EI is E bar square, deviation square, sum of them, I from 1 to n, right? 1 to n, divided by degrees of freedom. For simple case, single random variable case, we divide by what? N minus 1 degrees of freedom was n minus 1. How about this case? This is what? Mean of error, always 0. So EI square summation divided by degrees of freedom. EI is what? This one. Okay. Residual is yi minus beta 0 hat minus beta 1 hat xi squared. So in this case, how many parameters here, how many parameters estimated? How many here? 2. Okay. So degrees of freedom is number of summation, this part, how many? N many, minus number of estimated parameters. So 2, n minus 2. Can you see it? Okay. I told you degrees of freedom is number of independent items. Well, here, xi minus x bar square divided by n minus 1. So this deviation squared, how many? 1 to n. So number of independent items here, numerator, is n minus 1. But in this case, I explained number of degrees of freedom is number of summation n minus number of estimated parameters, too many. So n minus 2 is degrees of freedom in this case. What is this? Residual sum of square? Shortly, notation is SSE. So SSE over n minus 2. Okay, this is the estimate of variance. Okay, for simple example, let's see. Employee X, sales, amount of sales Y. We like to analyze this one, sales, amount of sales. We like to explain it, amount of sales with number of employees. Okay, so X and Y. It is a very simple example data. Employee, number of employees, 1, 2, 3, 4, 5. This is X. This X is Y. So 1, 1 starts. 1, sorry, 2, 1, 2, 3, 4, 5. 2, the sales is 1. here. 3, sales 2, 2. Number of employees 4, sales 2, and 5, 4. These are paired data, right? And we wanna get the estimated linear line here. So beta 1 hat is 0.7. Beta 0 hat is 2 minus beta 0 hat, right? X bar. Let's see. Beta 1 hat is, actually, you don't have to memorize this one, but if possible, you may memorize because it is very simple. Sigma xi minus x bar square. So here in this table, 1, 1, 2, 1, 3, 2, 4, 2, 5, 4 data, okay? Xi minus x bar product, yi minus y bar here. So xi minus x bar minus 2 times 1 minus 2. That is 2. Something like that. Okay? Okay. So some of them is 7. Some of them will be 7. The bottom line, denominator, xi minus x bar square. So 4, 1, 0, 1, 4. Some of them are 10. So 7 over 10 is 0.7. Is beta 1 hat, value of beta 1 hat. And the beta 0 hat is y bar minus beta 1 hat x bar. Okay? Y bar will be what? 2 over 5 here. What is, oh, y bar is here. 2. 2 minus 0.7 times 3. 3. So minus 0.1. Then the line will be like this, the red line, right? This one is a estimated equation or estimated linear line. So what is it? Intercept is minus 0.1 here, here, minus 0.1, and the slope is 0.7. Slope is 0.7. Okay? Very simple mathematics. All right. Then what is residual? yi minus yi hat. So yi hat means the value on the line here. So for 1, when x equal to 1, this value going to be what? 0.6, right? And next is yi hat. Yi minus yi hat is minus 3, point minus 3. This one is, I'm sorry, not this value. This value is 0.6. Okay. So 1 minus 0.6 is 0.4 residual. 1 minus 1.3 minus 0.3 residual. 2 minus this value, 0, 0, something like that. Okay. And what? Squared it. Residual squared value is 0.16, 0.090, 0.49, 0.36. So residual sum of square will be 1.1. Okay? And this sum of error is 0. That's why E bar, mean of residuals, always equal to 0. Okay? This value, sum of square 1.1, is the minimized residual sum of square. Understand that? Okay. I emphasize this one because this value, residual and the estimated variance, is important role in regression analysis. Okay, so it is very simple. It's short. So what we can denote it MSE. Okay, residual mean square or error mean square, MSE in ANOVA. So regression analysis is very much related with analysis of variance. Analysis of variance model is some specific model of regression analysis model. All right, that's it today. Thank you. Bye.